in a second session. Oh, that might not have been so good. Well, we'll see. So on this one, we're going to have point charge X is located at some distance from point charge Y. Charge X experiences a force. So where's my pen? So here we have point charge X, and here's Y. And point charge X experiences 18 newtons towards Y. So same setup as before. And then we say, okay, what would the force? What force would change? What force would charge X experience if the separation between the two charges were tripled? So for that, you've got to say, well, F is equal to KEQQ over R squared. And you're saying, well, all right, I'm going to change one of these so it's 3 times bigger. So can you intuitively tell me?
That's the separation.
Oh, it's the separation. So I'm changing the separation. So is it going to be, it's going to be less, isn't it? Is it going to be a third, or what is it going to be? If I...
It's going to be a 9.
It's going to be a third squared. If I triple the separation, it's a third squared, which gives me a 9th. So what was 18 goes to 2. Yeah? Now, I don't know what you feel about that, but that's a bit clumsy, I think, yeah? So there is a, and it gets harder. In this second one, I say, what force would charge X experience if the separation between the two charges were tripled? The magnitude of charge X was doubled, and the magnitude of point charge Y was quadrupled. So, first of all, it's okay on the test. If you're, I know we always have a number of people where it's like, it's the second language and quadrupled and quartered and all that. I don't mind that. I don't regard, if you ask me that, I don't mind. I don't think it's a technical term. If you ask me what does electron mean, then that's in our book, you know. But our book doesn't go through quartered and stuff like that. So if you just get, on a test, you get confused with that, by all means ask me. The test is not about that. But I'd like you to get it in time, but, you know. So then what we do is, the way we do these is we look at our basic equation, and I say F new over F old equals, and I want to find F new, and I know F old is 18, and then I say, well, it's just the ratio of the KE new times the little q new times the big Q new over the separation new squared divided by KE old, Q old, big Q old over R old squared. That makes sense. I don't know what the values are, but I know by what fraction they changed. So I know KE didn't change, so I'm just going to put down KE and KE. I could just cancel it out. But little q, charge X was doubled. So I don't know what it was, but it's twice as big now. And what about charge Y? Charge Y was quadrupled. I don't know what it is now, but it's 4 times what it used to be. And then the separation was tripled. So it's 3 times bigger than it used to be. And I've got to square those, of course. So then I look and I go, oh, well, that's all 1 on the bottom. So I get 2 times 4 is 8, 8 over 9. And here's the bit that people will do all this hard work and then they'll mess up on. You've got to find Fn. And Fn over 18 is equal to 8 over 9. So Fn is equal to 18 times 8 over 9. Fn is equal to 16 newtons. So it's a bit more formulaic. It's a way of laying out, whenever you get a ratio problem, do the new over the old, write it as a fourth-story fraction, start putting your ratios in, and you can cancel stuff out. And so what happens is people do this in their head and they kind of know how to do it, but they get it backwards and they get the wrong answer. Or people give me kind of like this little bit, kind of like over here, and they forget all about the fact that I gave you the 18. So they'll tell me the answer is 8 over 9. That's not right. It's not right. So the reason why I write down so many steps is because I want to make as few as possible slips in front of you. I want to get a good score with you as far as your confidence in me. And when I'm doing this, I'm under pressure. So I learned the hard way. The more I write down, the fewer mistakes I make. And when are you under pressure? You under pressure now? When are you under pressure in this class? On the test. So you're going to make more mistakes on the test than you will do any other time. So you need a strategy to not give points away for slips. And the way you do it, do the same thing I did. Just put more steps down. So that is, yeah, that's it. So draw a line under there. Oh, the cat right with that. That's my pen. Maybe that's why it wasn't writing. There's the test. Okay? The test will not include the next bits. Okay? Okay? Let's go to the next bit, though. I've only got like 10 minutes, so I'm going to set this off. All right, so we have 1, 2, 3, 4, 5 charges. And they're all affecting each other, and I'm interested in charge little q. So can you tell me, if little q is positive, what sign is this charge? If that's positive, what charge is this charge? It's got to be the same, isn't it? Because that's a repulsive force. And if little q is positive, what sign is this? Negative, etc., etc. One common misconception, which we've talked about in Physics 1, hopefully, is that just because this guy is here does not affect the force caused by the other two. If I did not have this F3 there, if I didn't have this Q3 there, this force would still be the same. Adding this does not detract from this guy. It just makes the whole vector more complicated. That's superposition principle. You can just add. You don't. It's not like my attention. If two of you are talking to me at once, I can't pay as much attention to one of you because the second person is talking to me. This is not like a human attention. This is like, one has an influence on me. It's not affected by the other. You have an influence on each other. That's a different thing. On me, I just look at what's influencing me and I add up the influences vectorially. So now I'll say, well, the total force or the net force is equal to the sum of all the individual forces. I is just a number that goes from 0 to the number of charges. And it's KE, little q, big Q, over R squared times RI. And I suppose you could do it. It's be long. What they tend to do to ask you problems about this is they tend to use a lot of symmetries. So things kind of get a bit easier. Questions are a bit shorter. And I got mixed feelings about these because there is a lot of symmetry. And the question is, do you spot the symmetry, not do you know the basic physics? It's kind of like... So this is one of those questions where the first time you see it, it's a real pain. And then once you've seen it once or twice, it's like, oh, you just know how to do them. So let's have a look at this. It says 4 equal charges, lay out points on the diagram. The magnitude of the force experienced by charge X. Where's charge X? The magnitude of this force, of the force on this charge, caused by Y. So I'm only dealing with those two to begin with. And it says the force of those is 3 newtons. It's going to be, they're all positive, so that's going to be 3 newtons. That's a piece of information. That's not really part of my problem. Because it says, what is the magnitude of the and direction of the force experienced on charge Z? So the charge Z that I'm really interested in. So just get me a piece of information. What it said was, when you're 2 meters away, you cause a force of 3 newtons. So charge Z will be affected by that guy. It will be affected by that guy. And it will be affected by that guy. And how big will those forces be? It's going to be 3 newtons because they're 2 meters away. And 3 newtons because they're 2 meters away. And 3 newtons because they're 2 meters away. So then what do I do? How do I proceed from here?
You need to get the X component.
So don't I need the Y component? Doesn't say anything about only X. It says what's the magnitude and direction.
Well, our options are only to the right, so.
But what do I do about the vertical?
Yeah, you need it.
Well, the verticals will cancel out
one,
actually,
then do the other
because
one,
the
then
3
add
newtons
one.
up and the 3 newtons down, the verticals of W and Z and Y and Z, those verticals are in opposite directions, so they should cancel out.
Yeah, so I'm trying to get a different coloured pen so you can...
So it should be 6 newtons to the right, because cos of 60 is half.
Let's go a bit slower, okay, because you're talking to an old man here.
Yeah.
And I can't get a different coloured pen, so I don't care. And now, yeah, okay. So basically you're going to go dot, 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 and you're going to go dot, 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 and you're going to go dot, 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 and you're going to go dot, 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 dot. Well, this here is going to be 3 sine 60. Where did that 60 come from?
Because it's an equilateral triangle, which is 60 degrees.
How do you know it? Because it's got equal lengths. So there's a bit of straight line. That means if that's, is that right? Did I do that right? 30 on that side? Yeah. So that's 3 sine 60. This is minus 3 sine 60. So those guys cancel out. Yeah? And then this guy here would be 3 cosine 60. And that guy would be 3 cosine 60.
Which is 1.5.
So I have the fx is equal to 3 plus 3 cosine 60 plus 3 cosine 60. So fx is equal to 3 plus 1.5 plus 1.5. So fx is equal to 6 newtons to the right. And I just find that it's the overwhelming thing is do you get the symmetries and all that. It's not do you know that equation. It's not do you know the superposition principle. It's like yeah. So okay, and then this last I've got a few minutes to just set this up. So all right. So the important thing is the force that a charge feels, and the charge feels, and it turns out that if I go to the Appalachian Mountains, and I want to go on a hike, does my map have to include all the mountain tops of all the mountains that surround me? Or can I have a useful map that just gives me the valley that I'm going to walk through? I don't need to have the mountain tops, do I? Well, it's kind of like that it's kind of like that with, let's see if I can do this now. This would be so cool. Kind of. Yes. What does it say? Cancel that. No, so yeah, here's a mountain, and here's a mountain, and here's a mountain. And I want to go through this little valley bit here. Well, you see, here's the thing, you see. Let's see if I can change my pen. Oh, no, it's over here side. So here's the thing, you see. Well, if I have... if I have something like that, then the contour lines, the red contour lines, will tell me if I'm going uphill or if I'm going downhill. I don't need the actual mountaintops. The map will just tell me that. So I end up with a map which has just these contour lines in it. And I can tell, I don't even know, is the mountain nearby or is it far away? It doesn't matter, does it? Because I know that if I go up here, I'm going to be going up a hill because I can read the contour lines. So there's one way of doing electrostatics where you say, you know, I'm at this point here, I'm at that point there, and I want to go to that point there, which is that point there, and so I need to take into account all the mountain tops and figure out what's going on. Or I can look at the effect of the mountain tops and just use my contour map And this is like using E fields. And this is like using point charges. We're starting off from here because that's what we know about. But very quickly we'll find that life is much easier when we use the electric fields. So what is an electric field? An electric field is a measure of the magnitude of electrostatic effect. Its units are newtons per coulomb. It's like little g. It's exactly like little g. And what that means is little g is more sophisticated than we thought it was, and more useful than we thought it was. We're going to call this big E, and it's going to be like, you know, it's going to be given all the deference of an important vector, just like really little g should have been given. And what we're going to find is that little e, it becomes our big E becomes our best friend. It's like, if I know the electric field at this point, 5 newtons per coulomb in that direction, how many coulombs do you want to put here? -6? +10? +34? So pretty soon I get thinking about fields, and I can put a charge anywhere I want, and I can just figure out what's going on. It really makes life a lot easier. So that's where we're going to go to next, okay? Next time there's a test, you're going to bring a pencil. I will provide the calculator. If you want to bring a straight edge, by all means bring a straight edge. Make sure you know your equations, because you're not allowed to use the equation sheet. Make sure that you remember that you no battery breaks, so you've got to go before you come, or you go beginning. And I want you to score really highly on this test. This is probably the easiest test. Well, that's not really true, but it's the easiest test that's coming up tomorrow, or the day after. So, yes. Oh, let me do this, because it's going to run forever.